welcome to Sustainability Forward, our podcast. This is the first episode of the new year 2024. And today we are here with you with a really hot topic. And the topic is, what is the 1.5 degrees Celsius global warming threshold? What does it really mean and why it is so crucial for us? My name is Wrishi, and as always, with me is my co-host, Carmine.
Thank you, Rishi, and hi everyone, and welcome to this first episode of 2024. Really excited to start this year with this topic. This 1.5 Celsius degree number is a buzzword in climate discussion, but what does it actually mean? So this is what I'm trying to demystify today.
Absolutely. And it's a very good question because we hear about it, we talk about it. Today we'll try to define that, right? So the 1.5 degrees essentially refers to the global average temperature rising no more than 1.5 degrees Celsius when compared between the pre-industrial levels and the year 2100, right? So in that period, the expectation would be that the global average temperature would not rise more than 1.5 degrees Celsius. And that was the goal that was set in the Paris Agreement back in 2015. So what is 1.5 degrees Celsius, why it is so critical? We're going to discuss that in our podcast today.
Yeah. And Rishi, I found it also very interesting to answer this question, to start from the very beginning of the Earth history, because there you can find some interesting path in the relationship between the temperature changes and also when you look at the last 10,000 years about the human development.
Yeah.
Now, the latest 11,000 years is what has been called Holocene.
Indeed, and I think we've referred to this in our in one of our previous episodes. In this long period of 10 to 11,000 years, which is called the Holocene period, what has essentially happened is that there has been a period of climatic stability, right? So the temperature in this long period has varied by only a few degrees. While in the previous periods, so the periods preceding the Holocene period, for example, in the Ice Age, the climate was not nearly as stable. That's why this period or the temperature change in this period is considered as a reference for what we are trying to target today.
Yeah, this Holocene steady state is believed to have played an important role in the human development. It is a warm, stable climate that facilitated the development of agriculture around the world, which in turn made possible the flourishing of what we know as Homo sapiens. So the archaeologists used the Holocene epoch as a time standard against which they trace the development of early civilization. However, it's important to note that the relationship between the Holocene epoch, climate stability, and the human development is, anyway, we know is complex, is multifaceted. While the stable climates definitely provided favorable conditions for human development, it is not the sole cause of it. Other factors such as technology advancement, social organization, and cultural practices also played a crucial role in the human development.
Absolutely, and that's why it's so interesting, right? Essentially, exceeding this 1.5 degrees means that we could leave this Holocene period, this Holocene steady state that has essentially meant, stability for a period of more than 11,000 years, right? So it's quite a risky thing we are looking at when it comes to exceeding 1.5 degrees Celsius.
Now, let's look at one latest, more recent data point. So if we look at the latest WMO, so the World Meteorological Organization report, We just saw that 2023 was the warmest year on record, reaching already nearly 1.5 degrees Celsius above pre-industrial levels. So are we already out of time?
We are not, right? This target of 1 point, or this threshold of 1.5 degrees that we are talking about, it actually refers to a long-term average and not a single year's data, right? By that token, in many years we'd see, temperatures increasing by 1.5 degree Celsius, but in this case we are referring to a long-term average. It is the global average temperature trend over decades.
Got it. So it's more than about a consistent partner rather than the occasional spikes in temperature. This also means that on yearly basis, we could actually reach the 1.5 degrees quite quickly.
Exactly. And another important thing to note here is how different regions or different parts of the Earth are experiencing this warming. As an example, the Arctic has warmed up nearly 4 times faster than the global average since the year 1979.
Yeah. But why exactly 1.5 degree? Why not 2 degrees Celsius?
Yeah, that's a good question. The choice of 1.5 degrees Celsius is actually based on scientific assessments of the impacts of climate change at different warming levels. Uh, at beyond this 1.5 degrees Celsius threshold, there are many significant risks and impacts, like extreme heat waves, very significant sea level rises that we are expected to have, right? That is what science tells us. And it's not just a question of if we overshoot 1.5, it's also a question of how we get to 1.5 if we ever do, right? So getting to 1.5 on an average very quickly would be far worse than a slow rise to 1.5 if we really have to get there, right? And to understand, as an example, to answer your question, why, for example, 2 degrees Celsius is way more worrying than 1.5, we actually have to look at some tipping points that are critical in the discussion of 1.5 versus 2 degrees or any other targets, really, right? These tipping points are critical thresholds in the Earth system. Once they are crossed, they can lead to many irreversible changes. So we'll discuss and try to test out some of these tipping points at 2 degrees Celsius.
Interesting, Richie. So let's look at some example there.
Yeah. Well, one major concern that I certainly think about quite a bit is the melting of Greenland and Antarctic ice sheets, right?
Mm.
At 1.5 degrees Celsius, the rate of melting would be slower compared to the rate of melting at 2 degrees Celsius, right? That much we know. But really, at 2 degrees Celsius, this could lead to a significant trigger and faster and irreversible sea level rise, right? So between these two thresholds, the melting of these ice sheets could happen much more rapidly.
Yeah. So every fraction of degree really matters as we are closer to the 1.5 degree. So going from 1 to 0.5 to 2 is much more worrying than going from 1 to 1.5. So every degree makes the difference.
Absolutely, it does. And another similar example is the impact of thawing of permafrost, right? Because as we probably many of us know, if the permafrost starts to thaw, it not only will release significant amounts of greenhouse gases into the atmosphere, but it will also disrupt ecosystems and infrastructure in the Arctic.
And biodiversity. This is another major tipping point. At 1.5 degree, the ecosystem like coral reefs face significant stress. But at 2 degrees, the damage could be catastrophic. leading to extensive loss of marine biodiversity. And it's clear staying below 1.5 is not just about temperature, but protecting a web of interconnected systems.
Yes, indeed. But if we may, let's also, Carmine, discuss the concept of overshooting 1.5, right? Because that is every day turning out to be one of the realities that the world is facing. If that happens, can we come back from that?
Technically, yes, but it's a risky path. So, first of all, overshooting means we will need massive carbon capture to reduce the atmospheric carbon to bring temperatures back down. This approach is far more challenging and costly than preventing the overshoot in the first place. And as you were saying before, the damage done at 1.5 threshold also depends on how we get to 1.5. So if we overshoot and then we come back to 1.5, the risks are greater than just if we were gradually stabilized to 1.5, avoiding the overshoot. So we discussed the timeline for reaching this threshold, how they are changing.
Yeah, the timeline is an important part of this. Recent analysis have suggested that we might actually get to 1.5 degrees Celsius, sooner than anticipated, possibly as early as 2029.
Yeah, that's much earlier than the mid 2030s prediction. And what is causing this change?
A number of factors actually, and some of this we've discussed in our episodes in our previous season. There are many, it's a combination of many factors. It's got to do with policy changes. Uh, Better climate data analysis is now available. It's also very important to remember that um, that these are at the end of the day estimates, right?
Mhm.
And as our knowledge or our actions on this improves, these estimates also continue to improve.
Yeah, and the future isn't set in stone, so our action can influence these timelines.
Precisely, yeah. It's basically a reminder for the urgency and the importance of robust climate action that we must take now. So now maybe let's consider the implications of overshooting 1.5, right? It's not just an environmental concern, but there is a major economic risk associated with it as well.
Yeah, there is the cost of dealing with climate impacts increases with the higher temperatures. But how does this compare with prevention costs?
I think as you mentioned earlier, right? Technically, it is possible to come back, but for example, it will require significant amounts of carbon capture as an example, right? So prevention, in other words, not getting there is far more cost effective than the mitigation after the fact, right? For example, the cost of returning the temperature to under 1.5 degrees Celsius after overshooting, as I said, would require a lot of carbon capture capacity, which are already which are quite expensive, and to be honest, their scaling hasn't really happened so far.
Mm. So investing now in reducing emissions is more economical than trying to reverse the damage later.
Exactly. And while we can technically draw down carbon from the atmosphere, we've heard about direct air capture as a technology, for example. Many climate systems, like the ice sheets, acidity of oceans, would take centuries to recover, right? So the question really is, do we pay a little bit now, or we pay much more later?
It's clear then. So proactive action is not just about being environmentally critical, but also economically sensible. Now, Richie, there is still a chance then to avoid crossing this 1.5 degree threshold.
Yeah, there is still a window of opportunity, but but it's narrowing pretty fast, right? Scientists and policymakers have continued to emphasize, the need for rapid and unprecedented actions in reducing greenhouse gas emissions to stay within this limit. On our part, we have also highlighted many of these topics in our podcast.
Mm. Let's again over it. So, what are these actions? What they will entail?
Yeah, some of these we've heard about many times, right? But primarily, we are looking at uh, significantly cutting down our reliance on fossil fuels, enhancing the use of renewable energy, and improving the efficiency of energy usage across many different industrial sectors.
Yeah, and especially the third one is what often get lost in the discussion. So, improving energy efficiencies. Now, also looking at fossil fuels. Burning fossil fuels is a major contribution to greenhouse gas emissions. What's the concern there?
Yeah, the the crux of the issue there is that fossil fuels, which are produced from existing oil and gas operations, as they are today, even that is enough to breach the 1.5 degree Celsius limit, right? Initiating new oil and gas fields on top of those which are already in operation makes the problem obviously even worse and directly conflicts with our climate targets, especially the 1.5 degrees Celsius target.
So, from one end, we still need that level of energy security. On the other hand, further exploration would make these 1.5-degree goals even more challenging.
Yes. Yeah, and um, what we are seeing, across many countries is that many governments are, you know, uh, initiating plans or talking about plans that would indicate that higher production rate of oil and gas or sanctions to new oil and gas developments are continuing at a rate which might be double of what the 1.5 degree Celsius pathway would recommend.
Yeah. And by the way, we are talking about, you mentioned oil and gas, but there is also coal, so all the fossil fuel supply chain there. Now, just to wrap up now, Richie, so the science is clearly telling us there is a clear threshold as in the history as we discuss in our planet. It's also giving us strong evidence, as we saw in 2024 being the warmest year on record. Now, we understood as the potential effects of reaching this target also likely to be some catastrophic effects that we'll experience with our weather, that climate condition becoming more devastating. And we also understood that this would require a collective effort on the part of the public sector, the private sector, and the society to achieve success in this endeavor.
Absolutely, Carmine. Quite a sobering thought for our first episode of the year, but I think it's a reality that we are all facing as our planet. Also, 1.5 degrees Celsius is such a common buzzword, as you said at the beginning, that it was important to demystify
Yeah.
some of the confusions that are behind it. Thank you very much for joining us. And Carmine, thank you very much for taking us through this discussion as well.
Thank you, Rishi. Thank you all. Looking forward to next episode. Cheers.
Bye.